For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. Part 1. A. P. 403, Section 12.2, Problem 14, B. P. 408, Section 12.3, Problem 38, C. P. 413, Section 12.4, Problem 8, D. P. 413, Section 12.4, Problem 13, E. P. 414, Section 12.4, Problem 20. Solution to A. Since ln tan pi/4 equals 0 and sin pi/4 minus cos pi/4 equals 0, this limit has the 0,0 indeterminate form, which justifies our use of the L'Hospital's rule. mathhomeworksolver.com. Solution to a B. By plugging in x equals pi/2, we see that the limit becomes 1 infinity, which is an indeterminate form. In order to convert this form to one of the indeterminate forms 0/0, or infinity, infinity 4, which we can use the L'Hospital's rule, let us write. Therefore, we are interested in the limit which, when written in this last form, has the infinity indeterminacy, therefore we can invoke infinity L'Hospital's rule to yield. Therefore we have mathhomeworksolver.com. Solution to a C. We already know that in case you forgot this formula, its derivation is as follows: let u equals e minus x and dv equals cos x dx, and integrate by parts to obtain one more integration parts, now with u equals e minus x, and dv equals sin x dx yields which, upon rearranging and dividing both sides by 2, yields the formula 3. Therefore, mathhomeworksolver.com. Note that the limit lim infinity e minus b, sin b minus cos b, equals 0, because e minus b vanishes as b tends to infinity, and sin b minus cos b remains bounded, namely its values are always in -2, 2 for all values of b. More precisely, this is a consequence of the squeezing lemma, and -2e minus b less than or equal to e minus b, sin b minus cos b, less than or equal to 2e minus b, with the observation that both plus or minus 2e minus b tend to 0 as b tends to infinity. Solution to D. First off, we observe that the required integral is improper, because ln x/square root x blows up, or down, to minus infinity at x equals 0 plus. Integrating by parts with u equals down, to minus infinity at x equals 0 plus. Integrating by parts with u equals ln x and dv equals dx/square root x, we obtain /square root x, we obtain. Therefore, it is straightforward to evaluate the required improper integral as. While the first limit is clearly 0, we need to resort to our friend L'Hospital for the evaluation of the second one, as it is in the indeterminate form infinity. This yields mathhomeworksolver.com. Therefore, the improper integral converges, since we did not get any divergent limits, and it is equal to. Solution to E. Recall the disk method, we have dv equals pi y2 dx. Now that we have infinite domain, we need to be a little more careful. mathhomeworksolver.com. Part 2 Problem 1 Solve Problem 21, p. 414, Section 12.4 of the textbook. First solve E. above. Solution to problem 1. We recall that the infinitesimal element for the surface area of revolution is d equals 2 pi y ds, where ds equals 1 plus dy 3 dx, 2 dx. Therefore d equals 2 pi 4x minus 3/4 square root 1 plus x minus 7/2, and hence the surface area can be written as which diverges to infinity. By the comparison test, we conclude that the integral 1 infinity diverges to. Problem 2 Solve problem 2 from exam 4 using the disk method. In other words, use the disk method to compute the volume of the solid obtained by revolving about the y-axis, the region in the first quadrant bounded by the z-axis, the line x equals 0, the line x equals a and the curve. MathHomeworkSolver.com. Solution to problem 2. Since we are revolving around the axis, dv equals pi x2 dy equals pi, y plus b, 2 dysprosium. We also observe that when x equals a, we have y equals 0, and as x 0, we have y infinity. Therefore, the limits of integration are 0 and infinity. Hence the volume can be calculated as MathHomeworkSolver.com.